National 5 Maths, Unit Test 1, Expressions and Formulae. This is Part 4. The fourth homework my class has been given on it. If you can do this bit, you will pass Part 4 of your unit test. This part of the unit test is dealing with applying geometric skills linked to the use of formulae. In other words, calculating the gradient of a line, or calculating the area of a sector, or the length of an arc. So this one's hopefully quite straightforward. So we'll let you have a look at the questions. So we can pause and have an attempt. So number 1, find the gradient between these 2 points. So we have A and B. So underneath coordinates of A, I would write x1, y1. Underneath the coordinates of B, I write x2, y2. That's so that I do not make a mistake when substituting into the formula. Remember, the formula for a gradient is y2 minus 1, y1 over x2 minus x1. So that would be 7 minus 4 over 5 minus 3 when we substitute in, which is 3 over 2. And part B, essentially we're just doing the same thing again. So x1, y1, x2, y2 underneath the coordinates. Substitute in negative 5 minus 0 over negative 1 minus minus 4. So that minus minus will become a plus. So we get negative 5 over minus 1 plus 4, which is negative 5 over 3. On to question 2. Given 3 sets of coordinates, asked to find the gradient and also to say which of the lines are parallel. So again, x1, y1, x2, y2, write down the formula for the gradient, substitute in the values. Note it's 5, subtract negative 3, 3 subtract negative 1, which comes to 8 over 4, because subtracting a negative results in a positive. 8 over 4 is 2. Part 2, again, same thing. We have the coordinates, x1, y1, x2, y2. Formula, substitute in, we get 9 over 7. On to the third part, E and F, x1, y1, x2, y2. Write down the formula, substitute in. 8 over 4 is 2, 8 divided by 4 is 2, minus divided by minus is a positive, so we'll just get 2. Question also asked, which pair of lines are parallel? Parallel lines have the same gradient, so AB and EF will be parallel, as they have the same gradient. On to question 3. Calculate the area of a sector that has a central angle of 65 degrees and a radius of 9.6 centimeters. So there is a very rough sketch of that. The fraction of the circle that we have there is 65 degrees out of 360 degrees. So the area of a circle is pi r squared. We don't want the whole circle, we just want that fraction that is shaded, so that would be 65 360ths. So the area would be 65 360ths of pi times r squared, which would be 65 over 360 times pi times 9.6 squared. Just type it into the calculator, and rounding to 1 decimal place, we get 52.3 centimeters squared. Part B. Wants to know the length of the arc again. Okay, so the length of the arc is this part here. So the formula for the circumference of a circle is pi times diameter. Remember, diameter is double the radius. And we just want 65 360ths of that circumference. So 65 over 360 multiplied by pi multiplied by 19.2, which comes out as 10.890, etc. centimeters. Question asked us to round it to 3 significant figures. Remember, significant figures, guys, 1 to third number along is 1 decimal place, so in this case we're going to round it to 1 decimal place. And that is the fourth part of it.